Hi. Now we are at the set. We saw array list, then the linked list. Let's look at the diagram again. We have iterable, then collection is the extended interface. Then we have three more extended interfaces: set, list, and queue. In the earlier two videos, we saw list. We have a class abstract list implementing the methods in list, collection, and iterable. We saw array list as well as we saw linked list. Now we are switching to set. Set is another interface which is extended from collection. There is one more interface, sorted set, which is extended from set. There is another navigable set extended from sorted set. We have tree set here. Other leg over here is the set interface has got a class abstract set which implements the methods in set, and then you have a concrete class HashSet from the abstract set. See, you need not remember all this, but you should know from where you have reached to HashSet. Okay, so we are going to look at the HashSet in a demonstration. Go there. Simple, we are going to see how to create a hash set of integers. Now you have to remember that any collection which is element collection in Java should have the list of objects in it. It cannot have a primitive data type elements collected together in any of the collections ready-made data structures. So when we wish to declare a set, we are going to say set, which is of an integer, name as set A equal to new hash set integer, open close parenthesis. Now this integer with big I or capital I is actually a wrapper class which takes in integer values as input and instantiates using those values the objects of integer class. That is what we will be doing here. So there are two reasons to show you 3, 4, 5 elements getting added into the set A. There is a difference within the array list, linked list, and the set. You can access a particular element in the array list and the linked list using an index number, while as when you're trying to insert the elements in the set, there are no indices when you try to get a particular element from the set using the index. That's one. The other is when you try to insert certain elements into a set, the order of entry of elements is not maintained. You will be able to get the display of the elements in any order. So in a set, that is hash set or tree set, the order in which you add the elements into the set is not maintained. While as when you add certain elements in the array list or linked list, the order in which you add the elements is maintained. It is always the case that the elements are appended as the last elements. If you want to do something different than appending the element as the last element, then there are certain different methods for it. We'll come back to that after we have had a complete journey of all the data structures which you have under collection. So back to the set. We have set A with certain elements. Then we have set B with 3 elements. We have set C also. You have to figure out where we have initialized set A set B, and set C from the code. It's like set A is initialized here, set B as the hash set is initialized here, set C as the hash set is initialized here. See how it is declared. On one side you have got set, which is of integers. So in the element type we have written integer. Then we have written the set name, set A or set B or set C. Followed by that we have initialized it as a blank hash set to begin with, so far as all the three sets are concerned, and eventually we are adding one by one element into them. Now, one thing you have to remember that a particular set or a hash set can accept an element as a null. You cannot have duplicate elements in the hash set. Now set A, set B and set C. Now we have initialized and added certain elements in set A. We have initialized and added certain elements in set B. Now see over here what we have done. Set A dot add all set B means what? Whatever elements are there in set A, to that add the elements from set B which are not present into the set already, because any hash set will not allow duplication of elements. All elements will have occurrence once. Okay, so set A dot add all set B will give you union set operation using set A and set B. Then what gets modified? Set A gets modified as the union. This is clear. This you will be able to see. Now look at set C. There are certain elements which are added in set C. Now we'll check whether set B is a subset of C. How do we do it? We have to check whether set C contains all the elements in set B or not. That we have done, and you get a Boolean answer. So you'll either get true or false. Now we are interested in getting the intersection of set A and set C. How to do it? It is through retain all. So the mathematical operation union, intersection and subset are done through ready-made methods which are there in HashSet. So let's run it. This is first one is set A. Now set A modified as union of set A and set B. We check whether set B is a subset of C or not. Over here it is not a subset of C, so you got the answer as false. And intersection A and C, you got this. Now what for we are getting a 2 over here. Let's go back and check. Set A dot retains all set C. For that we have got true, and then eventually we have got set A dot toString. So we have got the answer as the last display equal to 1, 22 and 10. You find that 1, 22 and 10 are the common elements within set C and set A. Remember, set A is the implicit argument dot retain all. Set C is the explicit argument for the method retain all. So What gets modified is the implicit argument, that is, the elements in set A will get modified. That means now the set A will have intersection of origin set A and set C. That is why you are getting the display as 1, 22, and 10. You'll find that over here the order is not maintained. Okay. Yeah. So using this, certain methods which were there in the HashSet or which were applicable for HashSet, we saw that it is possible to come up with union of sets, intersection of sets, and a subset mathematical operation. That is what we have seen in this particular video. So let's stop.